Okay, so what does this problem say? How many turns must be wound on a flat circular coil of radius 20 centimeters in order to produce a magnetic field of magnitude 4 times 10 minus 5 Tesla at the center of the coil when the current through it is 0.85 amps? This magnetic field is roughly the strength of the Earth's magnetic field on the surface of the Earth. Okay, so anyway, what we want is here's a circular coil, radius r, and if it's carrying a current like this, if you the magnetic field at the center will be pointing up. You can use your right hand to figure out that the magnetic field is like that. Okay, the magnetic field along the axial points is given by the strength of the magnetic field along the axial point is given by mu naught Okay, my pen has run out of charge, so I'm charging it for about 10-15 seconds and then we'll get going again. I just want to get enough charge to finish this problem. Okay, here we go. So mu naught n I r squared 2 times r squared plus z squared to the power 3/2. Z is the distance along the axis. So for us, Z is 0. So at B at the center of this loop, at the center of the coil, B is mu naught n I r squared, and the denominator becomes Z is 0, so r to the power of 3/2 is r cubed. Okay, and so it's mu naught n I, mu naught n I over 2r. Okay, and now we can put all the values in. Mu naught is 4 pi times 10 minus 7 Tesla meter amp. N is the, how many turns would be wound? Okay, so N is what we're trying to find. Okay, let me back off here a second. So N would be B times 2R mu naught I. Okay, let me work this out on a new sheet. So let's add a page below. Okay, so N is B times 2R mu naught I. Okay, so the magnetic field is 0.85 and the magnetic field is 4 times 10 minus 5 Tesla. Two times R is 20 centimeters, which is 0.2 meters. Mu naught is 4 pi times 10 minus 7 Tesla meter amp. Okay. And the current is how many turns? 0.85 amps. So and you see all the units cancel, so n is just a number. Okay, let's take care of powers of 10. So this is this comes up, becomes plus, that's 10 to the 2. So that's 400. We'll spend 1 here too. 4 times 40. Oops. Okay, so what were we saying? Okay, so we'll keep it simple. 400 times 2 times 0.2 divided by 4 pi into 0.85. Okay, so that's the number of turns, and this is equal to, so that's 40 times 4, 160 divided by 4 pi into 0.85, and this is equal to 14.9798, which is 15 turns. 15 turns in that loop will give you, so 15 turns a wire in a loop that's has a radius of 20 centimeters, carrying a current of roughly 1 amp, is going to give you a magnetic field as strong as the Earth's magnetic field at the center. Okay, so that does that problem. That finishes that problem.